Hi guys, welcome once again, and this is the question we have for today. What's in November 2017? Question 7b. This is a berry question. It says that a ship sails 5120 kilometers from port S to port Y on a bearing of 345 degrees. It then sails 448 kilometers on a bearing of 0.75% to port Z. Calculate correct to the nearest whole number, the distance from Z to X, bearing of Z from X. Then C says the time it took to sail from X to Z through Y at a constant speed of 120 kilometers. So let's jump straight in. I have my solution here. Okay, so I have the first one. It says from X. So let me put my X here. See, my X is here. This is my X here. I hope you can see this is my X and this is my North Pole. So I'm saying that it sails on a bearing of what? 345. So here is 90, 90, 180, 270. So I need 75 here. So here will be 75 degrees. I hope you can see it. Here will be 75 degrees, and then to sail to this place. So let me name here. This is my North Pole. This is Y. So if here is 75, position here will be 75 degrees. Yeah. Alright. Then it then sails so this distance from X to Y is 51220 kilometers. Then it then sails to what? Z on a bearing of 75. So I have from here to here 75. Therefore I have my Z here. So here is 75 degrees. That's the bearing. So here will be 15 degrees to give me 90. Then I have my Z over here. My North Pole is here. This is my Z. Alright. So I'll just join this and this together. Yeah, there should be some small space over there. So I just join this and this together. So this is the diagram I'm having, but I have to measure my distance that it measures from what? Y to Z. They say remove on the sails 448 kilometers. So that's it. So this is my diagram now on a bearing of 345 degrees to Y, then on a bearing of 75 to Z. This is the distance, this is the distance. Now immediately I'm using my red pen. You can see that here is 90 degrees. Therefore this triangle becomes what? A right angle triangle, right? Then we are asked to find the distance from Z to X. So from Z to X, so we want this distance. You can see that 90 degrees is facing this side, so this side becomes what? The hypotenuse. So we use what? The Pythagoras theorem to solve this. Therefore we have that X Z square is equal to the square of the sum of the other side. So we have xy square plus yz square. So xz square will just give me xy square, which is 5120 all squared plus 448 all square. If I remove the squares, I'm going to get xz is equal to square root of 5120 square plus 448 square. If I count that on my calculator, that's going to give me xz to be equal to 5139.56. Then I have my xz to the nearest whole number 5139. When I run it, so it will be 340. They said to the nearest whole number, so 340. So this is my first answer for this one. That's the distance from Z to X. Now we want to find the bearing of z from x. The bearing of z from x. That is what we want to find now. Alright, let's find the bearing of z from y. So to get the bearing of z from y, we need to get this angle because it moved from here to this place. So let me just use my red pen. It's moving from the north pole over here, from here to here to here. So that's the bearing of what? Z from x. Therefore, to get it, since we know from here to here is 345, you have to put theta here and look for this theta. So since it's a right angle triangle, the theta is facing this side become the opposite, this side become the adjacent. So we can use what? Tan theta. I'll take my pen back. Then we have tan theta is equal to opposite, which is what? The yz over adjacent, which is what? The xy. So half tan theta is equal to 448 over 5120. If I crunch that, I'm going to get tan theta is equal to 0.0875. Therefore, I'll find the inverse. So tan inverse 0.0875, and that gives me 5 degrees. That's my theta. Therefore, to get the bearing, the bearing of z from x, the bearing from z from x will be equal to, of z from x will be equal to 345 degrees plus 5 degrees, which will be equal to 350 degrees. So that's the bearing of z from a. So now we have solved for the a over there and the b. So now we are going to solve for the c. The time it took to sail from x to z through y at a constant speed of what? 120 kilometers. So we'll just solve for z. Let me just shift this one to the top. So I'll use my new sheet. I wanted to do it there, but I wanted to do it on my new sheet so the time taken will be equal to the time taken from x to y plus the time taken from y to z. So that's what we are going to take. What we are coming to do is what? The time it takes me to move from here to here plus the time it took me to move from here to here. That's what we are coming to do. Yeah. And I hope you had it correct. So let's move on now. This is just going to give me the time it took me here is going to be what? 5120 kilometers over my speed per hour plus 448 over my 120 these kilometers, 120 kilometers per hour. If I count that, it's going to give me 128 over 13 plus 56 on 15. If I do all my additions, I'm going to get 46.4 hours. To the nearest whole number, it's going to give me 46 hours. Note that the formula we use here was what? Time equals distance over speed. That's what I use over here. So that's what we use. So that's it for this question. So this is the time it took us to move from x through to y to z. I hope you are okay with this question. Please, if you have any comments or further questions, you can let me know so that I'll attend to it. Thank you for watching. If you like the idea, you can subscribe. See you next time. Bye.